Consider a triangle with sides of length little a, little b, and little c, and angles big A, big B, and big C, with the angles opposite the sides of the corresponding letter. Let's drop down a vertical line from the top of the triangle to the horizontal base B. This splits our original triangle into two smaller right-angled triangles, and we'll call the length of that line that we have dropped down h for height. Now, the area of that triangle will be given by 1/2 times its base, which is of length b, times its height, which is h. But if we consider the triangle on the right-hand side, then by definition, the sine of the angle C is the side opposite, which is length h, divided by its hypotenuse, which is a. Rearranging this, we have that h is equal to a times the sine of C. So substituting this into our original expression, we have that the area of the triangle is given by 1/2 times a times b times the sine of C. Now there was nothing really special about our choice of where to drop the perpendicular line from and which side to connect it to, so we could have done exactly the same thing, arriving at 1/2 b times c times the sine of a, or 1/2 of a times c times the sine of b. Formally, we have these expressions for the area of any triangle. Rather than remember them in terms of a's, b's and c's, the easiest way to think of it is that the area of a triangle is 1/2 times the length of one side, times the length of another side, times the sine of the angle which is in between those sides. To illustrate this, consider this question. Find the area of the triangle below. In this case, the angle that we know is in between two sides whose lengths we know. So this is in exactly the form that we want. We can therefore say that the area of this triangle is going to be equal to 1/2 times the length of one of the sides, times the length of the other side, times the sine of the angle that we are given. So using a calculator, we have that area is 23.1 to 3 significant figures. In this question, we have a triangle of sides of length 9 and 6 centimeters. We're told that the area of the triangle is 10 square centimeters, and we have to find the possible values of the angle x between the two given sides. So we know that the area, being 1/2 times the length of one of those sides, 9, times the length of the other side, 6, times the sine of the angle between them, the sine of x, is going to be equal to 10. So we can divide through by everything on the left-hand side except for the sine x, to leave us with the sine of x is 10 divided by 1/2 times 9 times 6, which is 10/27. Taking the inverse sine of both sides, we have the x being the inverse sine of 10/27 is 21.7 degrees to 3 significant figures. However, we are asked to find the possible values of the angle x. The diagram seems to give no possibility of another angle. How can this be? Well, this is another ambiguous case, as we saw with the sine and cosine rules. Although in this position, the angle x will be the 21.7 degrees that we've already considered, there is another configuration of this shape that will give us the same area. If instead of considering the original angle that we have just worked out, we use 180 degrees subtract that angle, then that will have the same value for the sine. So 1/2 times 9 times 6 times the sine of this angle will give us the same area. We therefore have that an alternative value of x would be 180 degrees subtract the 21.7 degrees, which is 158 degrees, again to 3 significant figures.